is highly experienced engineering manager at EPAM Systems and leading teams to design and implement cutting-edge solutions. Today, he will take us deep into event-driven architecture with .NET and Azure, showing us how to build resilient, scalable systems. And essential knowledge for anyone working in modern software development. His insights will help us understand how to design a system, not only work, but scale efficiently and remain robust under any conditions. Please join me in giving a warm, enthusiastic welcome to final speaker of the day, Erkin Mukhamedkulov, Engineering Manager at EPAM Systems.
Hi there. Hi. Nice to have all you here. Seems like everyone's a bit exhausted, yeah, guys? It was a long day. A lot of topics, a lot of AI, a lot of management, soft skills, and anyone wants more about AI? No, you don't. No, because I have nothing about AI. Luckily, you got the biggest AI skeptic in the world here on the stage. Remember this. I'm going to back to my cup again and again during the presentation. My name is Erkin Mukhamedkulov. I'm from EPAM company. I've been with EPAM for the last 5 years. Overall experience around 8 years in IT now. I'm luckily engineering manager. Anyone have an idea what it means? What does it mean in being engineering manager? Yeah, I know you know. That should be. Anyone? To be honest, no one knows. Have no idea. They just give us a target and say, hey, can you reach it? That's all. You should do it somehow. That's my title. And luckily, I have something to bring you today, and we will talk a lot about EDA. EDA, it's not Erkin-driven development, yeah, that's event-driven development and event-driven architecture. Let's start. Let's open the, oh my god, we start exact from the top point. Event-driven, anyone have an idea what's the event-driven mean? Yeah, 1, 2, 3, you of course know. Who else? Okay, there is an, thank you. Yeah, we have quite a good audience here. Things like, you guys can stand up here and do it by your own. You don't need me here, okay? But I'm going to share some of thoughts, my own. It can be wrong because nothing ideal in this world, luckily. And today we're going to talk about EDA. I'm going to say EDA because I don't want to overload you with event-driven architecture 100 times during the presentation. So if you hear EDA, it's mean exactly this. What's our agenda for today? It's going to be 4 main chapters. First, we're going to review a problem, why the EDA exists, why we can't use a classical, conventional request-response system, what's the purpose, what's the pros and cons. We're going to walk through the Azure toolkit, which we can use to build our own EDA systems. We're going to review theoretical. Unluckily, I have no time to build it and make it practical, but I guarantee I'm going to set up a workshop to do this in practice. We're going to review a theoretical example. It's a kind of a mind experiment how we can use EDA in the real world. Because without having example, theoretical knowledge is absolutely zero. You can't use it because that's a kind of philosophy without a practice. That's not a proper manner. And we're going to walk through the pitfalls. Because the pitfalls, it's a major step when you are facing something new. No matter what, it's going to be a cloud, it's going to be Internet of Things, it's going to be a blockchain, it's going to be a .coms. You know, I'm going back and back by the IT bubbles, and that should be a .com bubble, the biggest one and aged one, let's say this. So EDA, it's not a top-notch technology approach right now. Probably this day for this hype is missed already, and it's found his own place in all the variants of architectural patterns, design, and approaches we have right now. That's what happens with your new knowledge. That's what happens with any hype. Yeah, sooner or later it's find his own room and would be used in a very specific conditions. Pitfalls at the end would be funniest part. You will ask me a question, I will answer. I have no idea how to answer to this question, to be honest. So that's going to be a final part. Let's start from a problem. What's the problem is? Yeah. Why events? Event is a kind of something you're not expecting. Think about this. Yeah, request to your system, to your application is something what you are expecting to be here, today, tomorrow, after tomorrow. It's kind of a constant. Yeah, but event can happen or not for days, months, and after it can be an avalanche of events. So you don't want to pay some for a system which stays there waiting for nothing for days, weeks, decades if you configure it improperly and your event can't reach out to your system. It can be decades of a silence. So that's why, especially events can match to the real world examples. For example, I'm going to use the electricity system. In Tashkent, power outages is a kind of common stuff for us, and let's say how we can tune the system to tune this process about fixing the electricity grid problem, power outages, and etc., etc. Yeah, let's say any power outage should be an event in our system, and we should react properly. That's going to be our main idea. That's going to be our nutshell to the theoretical example after, which I'm going to show you after. Let's switch to another slide. Event-driven architecture. So event-driven, it's mostly the same stuff which you're using on a daily routine. Yeah, it's have a servers, it's have a code, it's have some kind of components, it's have some kind of tool sets which you are using, but they are organized a bit differently. Yeah, usually you have a server which on a standby mode, waiting for some activity and giving a response. Here in event-driven, you don't want to have whole system waiting for something happen. You want to have an entry point which will catch this events and say, hey, I know that should be operated by me, and I'm going to process it somehow. This stuff call it a producer. Event you can think about a messaging or screaming in a yard when you are calling your children, hey, back home. And no response. You know, they heard you, but no response. You know, they just start acting properly. That's exactly what event-driven architecture is. When you're screaming to your children in the yard and they start acting without responding, and you are going mad about this, certainly. Broker is a kind of a router. Which says, okay, I got this events from producers, I know what to do with them, I know what kind of rules I should set up, I know where I should send this event after processing it. Yeah, or I know what kind of components, applications should operate with them. And at the end, the consumers. When we're saying consumers, it's kind of someone who in a store buying or someone who building a house. No, consumers here can be a part of your system. Consumers can be another broker. Consumers can be another broker, and the system can go deep and deep. At the end, it shouldn't be a human. Ideally, because you're not building systems for machine only. I hope so, because you are solving real humans' problems. Yeah, and at the end, the user should be a human, but that's not necessary. Let's see. Okay, request response. Here on the top left, you can see a classical approaches, request response and how it works. And you can see the full diagram. Yeah, this is a full diagram for event-driven approach. They are not the same, yeah, but you can find something very interesting. But the request response can be inside the event-driven architecture. It's a normal when your components, whenever they got the message from you, responds you somehow and saying, yeah, that's right, or no, that's not right. That's not necessary, but it's normal. So, I mean, the EDA is more about the flexibility. You can use a classical request response approach here, but it's not necessary to you. So, request response, simple, tightly coupled. It means any components in request response architecture should be coupled with another one. You should know the routings, you should know the dependencies, you should cover it because it's always the risks. Yeah, something goes wrong and you get this dependency hell happening in your application or in a whole system. Even driven in another hand, it says, okay, I have a broker, and I don't mind what kind of application, serverless or maybe standalone application, maybe another brokers you're going to attach to me. If they subscribe it to me, I'm going to send a message, and I'm not mind what they're going to do with this message. But if they give me a response back, okay, I'm good with this, I know how to deal with it. So that's about low coupling. EDA is a low coupling, it sounds great, and it gives us a lot of a problem. We will see it later during the presentation. So, cascading failures, as I said, it's a problem of request response, and even driven can say, yeah, we have no cascading problem, but no, they have, that's a real problem. You should keep it in mind because any technology has their own limitation, and you can wipe out one of the biggest problems of the distributed system by using one architectural approach. There is a risk of a cascading problem in EDA as well, so we will cover it a bit later. Now, when we're saying, okay, you explained me in a general context, under the hood, how it works, yeah, what's the cross? We know it's already, yeah. Your system reacts exactly on something happens in the real world. For example, for our NET experiment, we will say you have an electrical grid which have thousands of scalar sensors, which sooner or later will say, hey, seems like a power is low or power outage here. And usually it's not just a one sensor for one area, yeah, usually it's hundreds of them, and they start screaming on you. In the classical request response model, if you're going to implement this monitoring system, you will be fully exhausted with these requests. You should deal with the grouping, you should deal with the touching, you should think about caching, you should think about how to close your application for new upcoming requests for for someone. No, not a problem for EDA in general, but still a problem if you are facing a really high input. Real-time reactions sounds really well, especially if you think about your system like producer and broker, and that's it, and you don't mind what's happening next. But if you think about your system as a whole ecosystem or a whole application, yeah, that also should be in your mind what's real time. It's not always the matter. It's not always a guarantee for you. It can be delays. It can be outages. It can be network problems. It's a real world. It's happened all time. And independent evolution. That one is really working well because you can isolate your components by the responsibilities, build a truly microservice system, and if you are deep dive in architecture, you will understand what the microservices is only about event-driven. Unfortunately, we can't build a fully microservices only on a request response model because microservices should be attached and detached easily. That's one of the requirements for microservices. And EDA gives you an opportunity to build a real microservice system. But it is not only the pros. There is also some pain points and trade-offs. Let's imagine you are building something really critical. Financial operation, medical information, emergency system, life care, or maybe operating the airplanes. No, you certainly don't want to have EDA there, because sending some information in such a critical areas, you should be sure everything goes well, and your case operated properly. Because if not, you should act immediately. There is a high risk. So in EDA, there is eventual consistency. You can't guarantee what the message is properly operated in some cases. You should do some workarounds about this. You should build some validation systems. You should build some status tracking systems to be sure everything goes well under the hood. And when you're doing this, sooner or later, you'll say, oh my God, seems like my EDA so coupled, so it's better to turn it back to request response. Yeah, it can be. Debugging anyone who works with the hundreds of the microservices, with the message brokers between them, even grids, everyone who faced with this bugs, which happens one time per year on a specific environment when the moon in the Mercury and it's last Friday in the month, you know how hard to catch this kind of bugs. Let's imagine all time when you work with a pure EDA, you will deal with exact the same problem and complexity of debugging, because tracking everything in EDA, it's a kind of a mind-blowing practice. Observability. No, in a request response, you can build your dashboards and build your logs on an entry. Somewhere in the middle, when you start asking in databases more, or from your facade service, when you're running to some critical services, and you can build one more very tough from observability perspective layer somewhere on the bottom. In EDA, everything should be tracked. Everything should be tracked and tracked properly, because if not, welcome, you lost your information, you have no idea what happened with your system. And everyone says, seems like it's not working, and you're saying, yeah, but my dashboards are green, so I'm good, I'm not going to fix it. So, infrastructure overhead, and not for the simple systems. So far, we know at least the main concept of the EDA. I hope we know. If not, you can scream on me and say, hey, Erkin, that's not true. Anyone? Nope. Yeah, I'm a lucky guy today. Usually at least one person, and I know this person, screams on me and say, no, that's not right. He's sitting right here, I'm waiting for his question. I'm watching on you. Okay, let's move to the Azure. Now let's move to our favorite cloud, and let's say, I want to build EDA in Azure. What kind of a doctorate degree I need for this? Nope, you need just common sense and walk through the guides, maybe a few hours. I know that's sounds like a hard job, hard one for you, but really, spending around a few hours to understanding the components, you'll be able to build your first EDA from scratch. And Azure provides everything for this. And everything from infrastructure perspective, and EDA is about infrastructure. You should have a proper message broker, you should have proper tool sets which works for you in your solution. Let's review it. Event grid, it's a kind of a pops-up routing. Simple one. Event hub. If your events coming unstoppable, it's a kind of a telemetry, and for our case, it's a real matter because we're talking about scale sensors. We're talking about real telemetry, so it's ideal to use Event Hub. Service bus, if you want to deal with your messaging without writing your own messaging system, you just set up a service bus somewhere in between your broker and your consumers, and operates with topics, with subjects, with the consumers, with the routines, and etc. Storage quiz, simple quiz for very basic messaging, and it's very powerful and very cheap, luckily. And Azure Functions Logic Apps. Here in the purple, that's just one thing you should write by your hand as a developer. All other stuff you can call your DevOps and say, hey, configure it for me. That's nice, to be honest. When someone say, can you build a system? You say, I can build a part of a system. All our system will build this guy. Okay, let's copy him. And this DevOps will say, nope, not again. I'm too tired about this. I'm going to be, I'm exit, so I'm done. To deal with this, we're going to use two different type of applications. Serverless sounds like ideal one for event-driven architecture. If you don't expecting any payload in your system, why you should pay for your computing resources, yeah? That sounds well if your functions in a standby mode cost you 0, and whenever you need them, they almost immediately executed, almost immediately. But if you need something more productive, if you need something more complex, and if you don't want to spend hundreds and thousands of credits on supporting serverless function whenever you got a huge payload, you better to use a classical logic apps. Cosmos DB, something where you are storing everything. Ideal to building your own logs and dashboards, especially if they are highly customizable, especially if your case is not in a Azure marketplace where you can just download some application infrastructure schemas and build it by copy pasting. That was here before white coding were invented. Yeah, someone just not stealing, they just downloading and whole system. That's a nice one. But if you are doing some really complicated business cases, you're going to use a Cosmos DB to store your dashboards, your telemetry, your logs, organize them, group them somehow. You want to have your own vision of the situation. Let's see how we can deal with it, especially with observability. From an observability perspective, I love Azure, to be honest. I worked both in Azure and AWS, and that's not a problem. I'm really in love with Azure, especially if we are talking about Azure Insights. That's something which from scratch gives you all information about your components, how we're acting, how the health status, health checks, out of the box, overcomplicated, overloaded with details. Your customer will pay for this, not your problem at all. But if you want to build something lightweight, you also can tune it, and it would take around maybe 25 years to tune it properly. Okay, function execution metrics, it's matter, especially if you're facing some problems and you can't catch it on the first level on Azure Insights or on some kind of a dashboards. Service bus queuing and dead letter quits. Here in observability, I know that dead letter quit is not kind of an observability tool, but the service bus it's from the box, so why not use it here as well? I'm going to talk about dead letter quits a bit more during the presentation. I hope no one fell asleep during this topic, because dead letter quit is kind of very interesting. My wife especially interested in this when I'm talking about this topic to her. Incident dashboards in the Cosmos DB and correlation ID for tracing. Correlation ID for tracing, it's not a kind of just an Azure tool, but it's again a part of observability, so it's going to be here. And the correlation IDs for tracing and tracing IDs as well, that's one of the most major practice from observability perspective if we're talking about EDE. So now we know the main concept, the toolboxes we can use, we know the pros and cons, and I want to drink my beverage. And if at this moment you think what all of this is not near to the truth, you again have a full right to scream on me. Nope, thank you. So good audience today. Let's try to use this and build at least a theoretical application. That's nice to list all these toolboxes, concepts and approaches, and without a visualization and a concept of a real usage, there is no chance you'll remember anything from this topic. We will have something called electricity incident reaction system. It's going to be one simple business flow with 5 steps. Something happened on a real world, on a sensor, on a scale sensor, smart meters detecting voltage anomalies. For example, somewhere in a subnet of your electricity grid, somewhere in your, maybe it can be your customers who informing you, hey, seems like I have no power here in my location. That also can be even producer, why not? Validation system which says, okay, it's a real event which we should deal with. It's not an info message, it's not kind of a junk or spam, it's not kind of outdated stuff, it's not kind of something we shouldn't worry about. For example, if your anomaly detector says, hey, looks like in your electricity grid there is a voltage minus 1 billion, for example. You don't want to operate with this kind of metrics. You want to just say, hey, looks like this metric system or this sensor is absolutely nuts. I want to call some support team to check it. That's a validation. Routing, we should deal with the critical and non-critical cases because not everything should be operated in the same way. You should have at least two different approaches for your one business logic. Happy pass and not so happy pass. And dispatch. Engineers and users who are going to react and going to fix the problem, and dashboard. You don't want to ask your non-software engineers in your centers, emergency centers, saying, hey, there is a logs here inside, search by you. You should know Elasticsearch, QUI, you should have a degree in computer science, and they say, I'm an electrician guy, I don't want to do this. And you say, I'm a software engineer, I don't want to do it either. So that's your problem now. Contract is paid, you should carefully read the documentation. So there is a two events we're going to deal with: voltage drop detected and power restored. Let's see how we can build it from scratch. Let's say, okay, we have a broker and we have a producer first of all. Smart meter, SCALA sensor, some kind of a sensor in the real world which says, oops, something goes wrong. We have a broker. We will use Azure Event Grid. We're not expecting for thousands of the events simultaneously. We're building a kind of a simple system. We're going to use Azure Event Grid, which will trigger the validation function. Why it's triggered? It's immediately when we're not using rules inside Event Grid. If you can use rules inside Event Grid, you probably don't need this presentation at all. You know how it works. For better visibility, we will decomposite this responsibility for two different components, and it's going to be validation function, serverless as usual, and this is we call initiation phase. Something happened, we are ready to react. Let's imagine validation rule says, yeah, seems like that's events which we should deal with. And let's say, first of all, it's not critical. For example, your power goes 5% less, and you configured your system to react to this as well. And it's not a problem to you, you know what it can happen due to some immediate usage right now, maybe some high voltage consumers just attach it to the network, started the working day. You know it's normal. You don't want to react, you don't want to disturb your supporting team, you don't want to disturb your dispatchers, but you want to store it somewhere. You don't want to lose information. Data is a new currency for us. Data is a new money. If you have data, you have everything about your system. If you losing your data, it's very, very bad from a customer perspective. Sooner or later, he will ask you, hey, can we do analysis? And you're not able to solve him a full data analysis team. And you're going to be fired as engineering manager. That's a non-critical incident, and what's going on? We have another grid. We're not going to attach functions directly one-to-one. Why? Because we want to avoid this cascading problems. We don't want to attach something to validation function and it starts spawning, and we have no boundaries, and it's spawning to another function, this one spawning to another function. You want to avoid it. Better to use another grid they achieve, so why not? Okay, your validation function said incident is critical. Let's say we have a service bus topic. Here we service bus itself, sorry for topic. We have a service bus which also a part of your flow, and validation function sends this event. Now the validation function is a producer for next level of your architecture. And here EDA works well as usual. You just sending message to service bus. It's have his own rule, this tool set, and it says, okay, I know what to do with this kind of messages. Let's firstly trigger out dispatch microservices or dispatch system, something you should have. Because you're not building your company from scratch, you probably engineer and they probably have something, and they have protocols to react to the system. Let's imagine they have something called a dispatch microservice, which notifies the end engineers. What's the brilliance of the system here is what in a service bus you can configure it to avoid disturbing the specific teams if they, that's not his area of responsibility. So you can limit by the rule and say, okay, I know there is a list of possible subscribers to me, which should have been notified. And I'm going to send exact messages exact to this microservice, or I'm going to send exact message to exact to this team who should react for my event. And at the same hand, you don't want to lose this data again. You want to build proper dashboard saying, ideally somewhere on a map, because your customer, like a child, they will love to see something on a map, especially if it's red or green lights, which are pumping. That would be nice to have this kind of a dashboard. Spend around 1 day to build it, and you'll sell the whole project, because showing the diagrams and components costs nothing for customer, but the final dashboard where they can find this network and say, oh my gosh, this looks brilliant, gorgeous, I want this, you can sell it. So this dashboard, we will use CosmoDB to store the live statuses, and we will have a serverless one more function to update the dashboard, because we don't want to write the message as is. Yeah, we want to deal with them somehow. Now, at this moment, we have just a free function which we're going to write by our own, and all our components we will configure by the as infrastructure. Ideally, if you have infrastructure as a code pattern inside your team, in this case, you can configure it just in repositories without disturbing the DevOps team, just calling your senior engineers and saying, hey, that's the time to gain a new knowledge. Today, you become from a .NET engineer to DevOps. That's it. I don't need all this fancy stuff. And we will be right, the system would work and still works somehow, because if you take a look for systems for our country, you'll see they are kind of a simple one. I know few of you guys had a chance to tune the systems, and my apologies. Now, we have this kind of approach. It sounds well, yeah? Sounds good. We know the main components, idea, problem statement, pros and cons. We know how to realize it via the Azure. We know the tool sets. We're ready to go. And I'm kind of sure if you start from this point without investigating a pitfalls, you'll spend thousands of customer credits, and we're not going to be happy at all, because you're going to build an unstable system which not works well. Looks amazing, but not works at all. Why? Because you're not deep dive in technology limitation. Any approach, any stuff, no matter which one, have their own limitation. There is no silver bullet in IT. There is no kind of just one stuff you can use everywhere. Everything have their own limitation and pitfalls. Pitfalls for that's my presentation looks bad, or this screen looks bad. Okay, let's say my presentation is my fault. Sorry for this. There is a kind of a different pitfalls. First, idempotency. Second, when you try to solve it, retry policy. Third, your system by the Moore's laws should be updated somehow. Sooner or later, it should going to be breaking changes, so you should keep in mind how to keep versions, how to track it properly, have an evolution, consistency, and resiliency. Let's start from first topic. There's going to be a lot of information on the screen. I'm not going to walk through all of this because I know your family waiting you don't want to spend whole weekend here with me till the Monday, okay? So in just keynotes, yeah, idempotency, duplication, losing your events, being sure you're acting right and whole flow acting right is a problem. Ideally, to use some patterns. Idempotency keys, any incident, any event on the very beginning should have his unique key. That's not enough. You will see what just having a key is not enough. You should also assign a group, or at least assign a specific markers to be able to group events, because they are coming unpredictable way. Yeah, they can be a 0, can be 1,000 at the same moment. You don't want to deal with all 1,000 because it seems like they can be a duplication. To avoid duplications or avoid the event flow and event avalanche, you should think about grouping events. But it's a topic for another slide. Here, you're just assigning a key. And for dealing with idempotency and duplication, you can use a classic idempotency key pattern. To use it in Azure, just two stuff. Azure functions have their own durable entities. That's adding some cost to support your Azure functions when you are using durable entities, because some magic happens on the back of your serverless functions, and it should cost something for you. And service bus with message ID and duplication detection. Duplication detection in a service bus is a kind of a premium tier. It's cost more. But if you are waiting for some really unpredictable throughput payload in your system, you better buy this. Because writing your own solution, you probably will spend a lot of money and a lot of time. Let's move next. Retry policies, poison messages, and dead letter quiz. Retry policies. For example, our mine system, which we might experiment, which we are building, have something called trigger maintenance team, trigger dispatcher service. And you want to be sure that the service triggered properly. So in your serverless function, you think, okay, there's going to be a request response here. I want to be sure it works well. I want to be sure it's operated properly, because losing this event from a support perspective is a kind of a risky one. And whenever you do this in event-driven, you found what, okay, it can be a problem with reaching out the endpoint. It can be a problem with operating with your message. It can be delays, it can be not network outages. What should I do? And usually you're covering yourself with a retry. Usually what you are doing, 3 retries, once per minute, that's it, it's enough. Or infinite retries till my servers will send me a huge bills. That's both correct if you reach enough, but I suggest to use a smart retry. It's a kind of a pattern with a circuit breaker pattern inside it. I'm not going to walk through the patterns itself, because we're not going to talk about gangs of 4 here. It's out of the topic. Just keep in mind there is a solution. Poison messages. Let's imagine your event somehow looks well, but having the proper information, which fully overloads your system, or maybe provides some glitches. And first time you found it, you can by the trace says, okay, seems like this message provides a glitches and Stack Overflow or something else in my application. I want to put it in a kind of a quarantine. So poison messages is a meta. When retries is exhausted especially. And if nothing helps, you should put any risky messages in a dead letter queue. You want to put it somewhere in your server's bus, which will say, okay, I have this queue, I know what it stores some bad messages, but I don't want to lose it. I know there is another metric system which should operate with us. I will hold them for a while, and after we'll send it for report. That's a dead letter queue pattern and concept. Service bus provides the letter queue automatically, use it. Now, let's move on. And contract version and schema evolution. Anyone on the very beginning of creating their own application or their own system thinks, yeah, that's going to be it for ages. No one will touch it any day. That's like in a concrete. No, of course. But anyone in this case thinks, okay, someone will update my system, and how we will do this? Again, no one. So we know the problem. Someone will go and update my system. Business logic will be changed. Real world will be changed. Somehow we should keep track our changes, and somehow we should have a proper technique for this. But that's not our problem. It's a problem for future me. Yeah. And this poor guy tomorrow woke up and say, "Oh my God, there is a list of the breaking changes. I have 5,000 serverless functions. I have 300 event grids and service bus components. I have an enormous number of consumers, and no one knows how to track breaking changes. I'm out. I'm exit. That's your problem, guys, now. So best practices is user versioning for breaking changes, and if it's not breaking changes, use a proper contracts. For example, easiest one, use a JSON if you're working with events as a data, because adding nullable field in a JSON schema will prove nothing if you have no strict rules somewhere under the hood. But if you have the strict rules, welcome, you in the problem. So JSON schema, async APIs, I'm not quite sure, but it's recommended somehow on Azure documentation itself. And Azure API Center, also something new I'm not aware of, so if you know better than me, please share with me your knowledge. I would like to hear your story. Now, ordering, casualty, consistency. Oh, that's a lot of stuff. Why we need the ordering in a system which acts independently? Why we need an ordering in a systems which acts with unpredictable payloads? Why we need the ordering if we are talking about events? Because your business flows usually have a start and end point. There is no way if something just starts. If something just starts and have no end point, probably your BA did his job wrong and poorly described the business process. To be sure, for certain critical parts of the system, you are following this proper business logic, you're going to set up ordering. You're going to say, okay, in some cases, my upper components can produce events which shouldn't be produced at this moment, and will get the events which already happened a couple of minutes ago. I want to be sure we are acting properly. I don't want to trigger the incident and say, hey, it's happened, and I will never close it, because even about power restoration, for example, in our example, happens 5 minutes ago, and you just get your power outage. So that's vice versa in a business process, and you should keep it in mind. But if you see what's power restored or end event happens, but there is no start event for quite a long time, letter Q, welcome. So out of order, late, duplicated, that's always will happen with you. And without proper tracing, without proper monitoring, you will be able to validate your system and understand what's going on and why it's not working well. To deal with observability and tracing again, because it's meta for EDA, you should use, as I said, some number of tools. But there is also a number of proper techniques. First of all, each event should have its own unique ID. That's meta, and it should be propagated across all components on any level. That's no excuses, they should be there, because finding yourself in the middle of thousands and thousands of events which you can't properly replicate, you can't properly understand, you can't properly trace, that's a nightmare for any developers of huge systems, enterprise components. Also, you should deal with a grouping. Imagine you have thousands of Scala metrics or smart meters somewhere in a field, and whole region is in a blackout. Power outage happens, bam, you have thousands of events immediately, you get this notification somehow, and without a grouping, you should send thousands of support team. But there is just usually two of them. One of them here in the capital, and others somewhere around the country.
You can't send 1,000 of line engineers. You don't have the resources, and this incident do not require this kind of interaction. You should group it. You should put a higher priority, saying seems like it's not a local incident, seems like it's a regional or another rules. So prioritization as well. To build a priority, you should group it. Without grouping, no priority. For example, incident ID, sensor ID, region ID, something like this. More you have, better visibility. Yeah, your schema goes to be enormously big, but okay, that's cost nothing for you. Come on. 1, 2, 3, 5, 10, 100 additional fields, not a problem. You always have a junior who writes this code, so why not? And even fan outs, I told a lot about this when thousands of events happens simultaneously. And one more problem. Whenever you build your EDA on the very beginning, you'll see some events happen, and after in a month, nothing happens. And you're so happy, you think, oh, it seems like it's everything okay, it's good. No, it shouldn't be. You should have a proper SLA. You should understand that periodically when something goes wrong. To do it, you measuring the normal payload and calculating anomalies and building your anomaly detector somewhere in your system. Or second one, you're just implementing a physical health check. One smart meter somewhere in an office or somewhere in a field which will trigger events periodically, and validation function will say, hey, I got this event, I'm not going to upgrade for this, but I certainly know the entry point works well. At least entry point works well, and Azure guarantees us 99.99999, not like in this time. Perfect timing.
Yeah.
Thanks a lot. You have another one? Oh, we have a backup. Oh, the matter of the backups.
It's a way.
Yeah. Properly built SLA will trigger the mic change 5 minutes before. Now, secure by design. If you know how to secure by design the EDA properly, probably you're not a part of this audience. And I can't give you advices here because usually it fully depends on rules and guardrails you have inside your company. Because securing it with just kind of let's say tokens, that's not enough. Securing it by just an access, by grouping, it's also not enough. Enough is enough when the security engineers will say, yeah, now it looks well. That's a level which you should reach out. But the cost optimization, that's one we always forget. Remember, you should put limits. For any components which can face high payloads, you should put limits. Without the limits, without the proper triggers, you sooner or later will find yourself poor somewhere under the bridge, paying the credits for your customer infrastructure. Because it's easily, in just a moment, can cost you 0 and after 1 million. But that's normal. That happens, and there is some real world cases where it happens and customer walks up and say, oh my gosh, I have a budget. Yesterday it was here, but where it is my money? And Azure will say, man, you configured it. We're not responsible for this, and you should pay. There is no excuses. It can be some, it can be some kind of help from Azure perspective. They will say, okay, you're not paying right now, but if you're a huge client, we will give you a trial. We will give you some kind of a period. But that's a business, you should pay. Keep it in mind, always. Use low-cost pop-up models whenever you want, whenever you can. Use standard models whenever against the premium, if possible. Batch processing whenever it's possible, because in some cases you can think what your serverless functions have a 100 gigabyte network, but it's not real true. Sooner or later you'll find what there is some limits, monthly limits inside it. And if you reach out the limit, you will face slow connection. For for some of the components, not for all of them. And auto-scale to 0 with functions. Auto-scaling to 0 can sound like a good advice, but here you also will ask me, hey, okay, Erkin, what about warm-up? Functions not act immediately if they auto-scale to 0, if they fully turn to off. You should pay for standby. And in this case, the question, I'm paying for standby for serverless functions. I'm implementing circuit breaker and retry policies for critical parts of the system. I have risks with events fanout, and cascading dependency also is here. What's the difference with the classical request response model? I don't know. They say there is some. That's probably it from me, and there is some kind of a summary, which I should have or not. We'll see. Yeah, summary. Pluses are here. One of the main and major, from my point of view, is IoT. Anyone remember IoT? Yeah, nice. You probably know what the IT bubble is meaning here, because maybe 10 years ago, IoT was everywhere. That's like another technology we're today talking about a lot. And everyone said, no, everything we're going to connect to internet, and all your things would be, all your devices would be smart. And you found what you don't need a smart toothbrush. You just need to brush your teeth. That's it. You don't need a smart microwave. What kind of task you're going to assign to your microwave? Yeah. You don't need a smart dishwasher. There is just one scenario when you have a smart dishwasher to show to your friends, and they ask, you paid for this? Yes. That's probably it. That's it from me. Any questions so far? Sure, I know it. Please give him a mic. This guy here hunting me from presentation to presentation. Each time I'm presenting something, he's here asking his question like I know something. No, I don't know anything. I have no clue.
Спасибо тебе большое, Эркин, за подробное описание идеи. Многие большие корпорации его действительно используют, но это является их большим камнем преткновения. Я хочу услышать твое мнение по поводу когнитивного воздействия event-driven архитектора на нас, на простых разработчиков.
Все плохо. Ладно, я отвечу на русском. Давайте так. Все, кто старше 30 лет, похлопайте, пожалуйста. Вы, вероятнее всего, учились на трудах Кнута, Фаулера, Мартина. Они рассказывали вам о том, как правильно писать код. Они рассказывали о том, как компоненты внутри вашего приложения должны работать. Но никто из них не рассказывал вам, как ваше приложение должно общаться с другим приложением, у которого почти нет никакого функционала. Они не рассказывали, как строить огромные паукообразные, паутинообразные системы, в которых каждая вещь конфигурируется отдельно, у нее есть своя ресурсная группа, у нее 1000 других параметров в YAML-файле, все это деплоится каким-то образом. И где, чтобы найти бизнес-логику, вы должны это все сесть, читать, а потом понять, что где-то в одном из сервис-басов есть настроенный топик, который вообще все рушит. Это не та вещь, к которой нас готовили, но, к счастью, современное поколение готово к ним. Микросервисы научили людей.
Пример Uber. Микросервисы.
Не знаю пример Uber. Я же сказал, ничего не значит, где спрашиваешь.
У Uber всем известная звезда смерти — это их связь, их микросервисов, которые они сейчас переводят на модуль монолит.
Наконец-то.
И они отказываются от этого. Не кажется ли тебе, что идеи вызывает дополнительную когнитивную нагрузку на нас, на разработчиков, что мы должны еще знать семантику домена, с которым мы работаем?
Несомненно.
Знать те события и воздействие на схему может сломать всех потребителей.
Мы можем жаловаться на это, но распределенные системы здесь, они никуда не денутся, и нам придется с этим что-то делать или искать другую работу.
За ними будущее.
Да. Но мы не готовы к этому. Новое поколение готово к этому получше.